Hello, my name's Rob and welcome to SwiftSlots. Now in this video I'm going to be building two new 1/43 scale diecast cars. One of them being this beautiful BMW M6 pullback and go diecast car, and the other one being this dinky Delahaye 145 vintage car from the 30s. Now these cars are very different, they're going to have very different performances, and I am building that in mind. So the BMW is obviously going to have performance in mind, and I'll be using nice wide tyres and so on and so forth, and the Delahaye is going to be using slimline tyres, so the performance is going to be marginal, let's just say. So if you haven't heard or seen about my new 1/43 scale chassis, the Mark II version, I suggest you go back one video to the video I made a couple of days ago and watch that video in its entirety, because I go through all of the brand new features of this chassis and also all the tyres that I've made to go with this chassis. And with this new Mark II chassis, you can have a whole range of adaptations for it, which can allow you to make classic cars like this with very narrow wheels on standard axles, and super performance cars like the BMW here with nice fat rear tyres and all the performance that you would expect from it. So I'm going to show you this BMW here being built step by step. I'm going to try and go a little bit slowly because I want this to be more of a how-to. And then on the sidelines off camera, I'll be building this Delahaye as well. But at the end of the video, I will show you both cars because they build very, very similarly, but the components are going to be slightly different. So I'll focus on the BMW, which is probably going to be a more popular car that people would build, a modern chassis. And then the vintage car will be more of a sideline. So at the end of the build, I'll show you the undersides of both of them and how they both look with their different components. Then we'll get them both on the track and we'll run them round. Now I'm not expecting huge numbers from the Delahaye, obviously, because it is what it is. It's going to have skinny back tyres and it's just going to be a looker, a really enjoyable car to drive, and she does look very pretty. But this car here will take a time for the BMW because I think it'll be very interesting to see what sort of performance we can get out of it. And if my memory serves, a decent time for a die-cast conversion around Crow Valley is about 56 seconds. I think it's about 56 seconds. So we'll see what they go like. Anyway, enough of the waffle. If you haven't seen this Mark II video, please step back one video and watch that one first and you know what I'm doing. Other than that, let's get to my bench and we'll start turning these cars into slot cars. So what parts are going in the BMW? Well, obviously we're going to put a SwiftSlots Mark II resin chassis in it, and then there'll be a Pendle Slot Racing 25k slim cam motor. I found these motors to be very fast and very, very strong. On the front of the motor, there'll be an MR slot car 8-tooth pinion, and on the axle there'll be the Slottic Crown Gear 24-tooth non-offset with the brass insert, and that will give me a gear ratio of 3:1, which is just about standard. The back axle is a standard Slotting Plus axle, and we've got Slotting Plus eccentric bearings so that we can adjust the ride height when the car is done. The back wheels are the Pendle Slot 13-inch wheels, which actually measure 11.5mm across the diameter and 8.5mm across their width, and the rear tyres are the new SwiftSlots PU tyres. And up front we got my very favourite standard Slotting Plus guide. So what parts are we going to put in the Delahaye? Well, obviously we're going to start with the SwiftSlots Mark II resin chassis. In it we're going to put the Pendle Slot 16k slim cam motor. This motor is obviously slightly slower than the 25k motor, but it's still pretty good with plenty of power, and it'll push this cruiser around the track really, really nicely, I think. So the back axle is going to be a completely standard Skeletrix back axle, nothing special whatsoever. And there'll also be standard Skeletrix nylon bearings, again, nothing special. The pinion is an 8-tooth MR slot car pinion as well, but this time it's a 5.5mm in diameter as opposed to the 4.5mm on the racing car. The rear wheels are, again, standard Pendle Slot 13-inch wheels. Same outside diameter of 11.5mm, but they're only 6mm wide to try and match the general width of the original car. And the tyres are the Pendle Slot MT tyres to fit these particular 13-inch wheels. Now the gear ratio between this pinion and this back axle is actually 3.4:1, so it's quite slow, because normally they're about 3:1. And this is also a slow motor, so a slow gearing with a slow motor, but with slow gearing you get good torque. So although this motor isn't particularly fast, it should give you quite a lot of power through that gearing, because this car is quite a heavy car, although when we start we've actually got a die-cast chassis which is really adding to the weight. But even without that chassis, I think the body is still going to be quite heavy. So we've got a fairly powerful set of gears and a sensible motor, so it won't overpower those back tyres. And again, obviously, we got a standard Slotting Plus guide to go up front on the Delahaye. So with all that said and all that explained, it's now time to get all this stuff off this mat and start pulling this BMW apart and turning it into a slot car. Okay, so every single 1/43rd scale car is going to come with its own challenges, and this BMW is no different, because every single 43rd scale car is basically a scratch build because they're not supposed to be slot cars. So the problem with this car, it's got a lovely flat chassis, but when you take away the chassis, the body is not nice and flat, and that's because some of the parts that we need for the body are actually on the chassis, which is no real problem. So what we need to do is we need to cut away the front bumper, rear bumper and the side skirts, and they'll need to be glued with super glue onto the body. Also, you'll notice that this car's got opening doors. We don't need that feature, and those hinges and screws are just extra weight that we don't need to carry around because these bodies are already quite heavy. So we need to open up the door or undo the screw, cut off those hinges, and then we can super glue the doors shut as well. You'll also notice that this glass is loose, and that is because when the car goes together, this parcel shelf is supposed to clamp the back of the glass, but I don't know if the parcel shelf is going back. So what I also need to do is rough up the inside of that glass and rough up the underside of that roof, and then I can put a little bit of epoxy resin onto that roof there and then stick the glass in last. And the reason why I will stick the glass in last is because we're going to be super gluing all the parts of the chassis into the body. We're going to be super gluing the doors shut, and if anybody knows, super glue can gas off and it can leave horrible white dust everywhere, and it can stain all the glass. So we get all the super gluing done first, leave that overnight to completely dry so there's no more gas, and then I can simply epoxy the glass into the car via the roof panel there, and then everything will be nice and we're almost done with the body. So let's crack out the screwdriver and the angle grinder, and we'll start chopping all this up, and we'll start neutralizing this body so it's something that we can actually use as a slot car body. Okay, so I'd actually just set my camera up to go into a fast forward speed montage, but I just discovered how easy this particular chassis is to come apart, and I thought I would document it because it's actually comically easy. I thought I was going to have to get a screwdriver in there and break stuff and get this all apart and just go mad with it, but it's actually really easy. The front lights simply unclip, the actual main interior simply unclips, the pullback and go mechanism, all you can do is pull that little tab back and just tip the whole thing forwards, and it comes out really easily, and the front axle just lifts out. But the best bit, these side skirts, they just literally unclip and come straight out, which is amazing, which means now all we need to do is just line them up with the body when we're ready and glue them straight in. Really easy. In fact, which way does it go around now? I think it goes that way. There we are, and it all self-locates in. All these little parts have little tabs. There's a nice big tab on there, so sometimes it actually works out quite nice, and life is easier than you think it's going to be. Right, so with that done, we can now carry on and start chopping out just the front and rear bumpers, which is a lot easier than what I thought I was going to have to do. that's the body completely finished. And as you saw, it really isn't very difficult at all. All I really did was chopped off the metal hinges and cleaned those up, chopped out the front and rear bumpers, and then trimmed off the mounting lugs on the side skirts. I then glued in the front and rear bumpers, glued in the side skirts, and then glued in this bonnet detail with super glue on the end of a cocktail stick, glued the doors in, and then once all the super glue was dry overnight, scratched up the roof and the underside of this glass, and then glued the glass in with 5-minute araldite. And once that was dry, just pop the dashboard back in with a little bit of super glue on those mounting lugs. Now obviously every car is different, but that's what this particular car needed, and as you can see, we're now ready to take a chassis. Now once the front and rear bumpers are actually in place, I left them over long when I cut them from the chassis, and then went in with my Dremel and I trimmed it all the way back as much as I dare to give me as much room as possible for the chassis. And as you can see, I've gone right into this back bumper here. I've gone right up to the back of the valance there, just touching the back of that plastic, and I've come just inside these two side strakes here because I want as much width as I can. My chassis wants to be as wide as it can be in that part there, but I didn't want to lose this detail. But as you can see, I've still got the detail on the back and I've still got the detail from the sides, so we're free now to use all that space for the chassis, and we've got good access to the rear mount, and we've also got really good access to the front mount, which may cause a problem actually because the guide wants to be right here, so we may have to do something slightly different in the front, but we'll get to that bridge when we get to it. Okay, so now we can turn our attentions to the chassis. Now this is a generic chassis and I have to make it fit the smallest bearing so that everything else can just be a case of opening up the hole rather than trying to put material back, because that would be very difficult. So the smallest bearing that I can find is the Scalextric nylon bearing. And as you can see, it's a really, really nice fit in the chassis as standard. Goes in nice and easy, nice little nip, and it's perfect. And obviously the bottom of the chassis is not at all stressed, it's completely flat. But that won't necessarily be the case for other bearings. So in the case of this Slotting Plus bearing, that's ever so slightly bigger than these Scalextric bearings, and I'll just show you now. So if I measure that bearing there, it's basically 4.65 mil in diameter. So if I take this 4.7 mil drill, you'll see that that is basically exactly the same size as well, 4.63, it's more or less the same. So if I put that drill into that hole, I can feel that it's a nice fit and there's not a lot of resistance to it, and everything is happy, and the bottom of the chassis is nice and flat. So that's great. However, if I measure the Slotting Plus bearing, that's 4.81 or 4.75, somewhere around there. So if I take my 4.8 mil drill and I measure that, there you go, 4.73. So this drill is basically the same size as that bearing. Now if I try and put this drill in, it's quite a bit tighter. And now I'm actually flexing the chassis and I can actually see daylight underneath my ruler. You might not be able to see it there, but I can. So that's bad. So this Slotting Plus bearing, if you were to force it into the chassis, could cause you problems. So what you should do if you're going to fit anything other than a nylon Scalextric bearing into the chassis is do this little check like I've just done and make sure that you've got proper clearance for the bearing you intend to use, because if you don't, you'll be putting a lot of strain across the chassis there and you could end up doing some quite nasty damage. Now obviously there's not a lot of meat there, but there is enough, so you need to check it. So if your bearing is a little bit too tight, by checking it with a drill, you need to file the holes just to ease the bearing in, and you can use the drill as a test. So this is the way that you would make it fit. So if you just take an ordinary round file and very gently, I'm just working on the side with my finger, this side here, just very gently file that until that drill feels reasonably nice in that hole. So there, now that's actually quite a nice, it's a feel thing. It's not tight, but it's not particularly loose. And then try this side as well. That side's actually pretty good. The next thing you need to do is make sure that the little pinch points at the top of that bearing aren't too tight. So we'll just try it. To me, that feels a little bit on the tight side. It just doesn't want to pop in really easily. So with a flat file, very gently, just have a little tickle at the little pinch points at the top of the bearing there. Again, you don't want much. There, now that's gone in there perfectly happily. So that one there is perfectly happy in that hole. So if I pull him out now and I try the other side, hopefully, no, a little bit tight. So let me just go around and do that side as well, because I didn't do that side just a minute ago, I only did the one side. Just gently nip those pinch points. I'm putting hardly any pressure on at all, and then try the bearing. There we are, I'm happy with that. Right, so that's gone in there nicely as well, and the chassis is not being flexed. So that's those bearings in perfectly happily, and there's no problem with those bearings. Now the next thing you might want to consider is, with the case of our body and the wheels that we're going to use, I've preset these wheels to the width that I'm going to probably finish up at, which is about there. So we got our gauge. Now if I just pop that bearing back out, I can show you the next thing. So if you fit those wheels in there, look at it from the underside, it might be easier. So you can see that we've got a good amount of gap. Now this might not be the case of really wide wheels, but in the case of these it's fine. So what you might want to do is use a selection of materials to go across this part here. So this is a piece of 2mm carbon fibre rod. So as you can see, you could glue a piece in there right across the back of the wheel, but it might get in the way of that wheel slightly, so maybe that isn't right. But you could also use this piece of 30-second piano wire. That will be absolutely fine. You could cut a piece about 1 inch long and glue it across there as well, just to reinforce across the bottom. You could also use a piece of copper clad, for example, which is just fiberglass board. You cut a strip of that and then glue it across in there to bridge the gap in there. Or what I'll probably do here, this is a piece of carbon fiber flat bar. It's 1mm by 6mm, and what I'll probably do here is cut a little rebate in it just on here, and then I'll glue a piece about that long, just coming onto here about 10mm and onto here about 5 or 6mm with a little rebate in there, and I'll glue that right in tight on both sides of the chassis. I have to take off the SW and I off of Swift, which is a bit of an oversight. Next time I do a new mold, I'll move that logo. So that then will bridge the gap between the front and the back and put a load of strength in here. So you're not really just relying on this resin here. So that's what I'm going to do in the next section now. I'm going to cut a bit of carbon fibre. I'm going to rough up both sides with a fiberglass pen and rough up the back of this. I'll put a rebate in the back of that with my angle grinder and the Dremel, and then glue a piece on that side and a piece on that side. I now know that my bearings fit nicely because I've just done it in front of the camera for you. So then what I can do then is offer my wheels in, get the spacings, the distance between the back of those wheels. So if I measure that there, and then I can apply that to the bottom of my chassis and just nibble the carbon fibre on both sides so that I know that when the wheels go back in, I've got good clearance for the back of the wheel. So let's crack on with that. Let's get this back axle in this car, and then we can move on to fitting the motor. Okay, so that's the back axle all in and basically ready to go. So here you can see the carbon fibre strips that I've added to the chassis to strengthen it up, and here you can see it underneath where I've scalloped it to clear for the wheels and the tyres. Now as I say, you don't really need to fit these carbon fibre strips or any reinforcing at all if you get your bearing holes reamed correctly and you're not putting strain on the chassis, but because this is a demonstration video, I wanted to do that job anyway, just to show you how you would do it if you actually wanted to do it. So on this particular car, I fitted the eccentric bearings and I've got the holes set up so that the axle is giving the most amount of ground clearance possible, and that means putting the dot at the very top of the chassis, lowering the axle all the way down. And there's a very easy way to find out how much ground clearance that you've got once you set up your axle in any position, or in this case, and it's the axle lower in the chassis. If you put your car on a setup plate and you take a drill and you put the drill underneath the chassis and push down with your finger, so you're pushing the back of the chassis and the tyres, you should find that when you get the right size drill bit, you have an exactly parallel gap across the bottom of the chassis. In this case it's 2mm, and that tells you that you've got 2mm of ground clearance because the chassis is nice and level. So I can afford to lower this car down. Now that's quite important because the next step is to fit the motor. So with these eccentric bearings, obviously you can adjust the height up and down, but that means rotating the bearing, which means you're actually moving the axle longitudinally as well as vertically. So if I want to lower this car down to maybe half of what these bearings can offer, I'm actually putting that hole slap bang in the middle of where a standard set of bearings would be anyway. Now I can do that one of two ways. I can either rotate them clockwise, which would bring the axle forwards, or anti-clockwise, which would bring the axle backwards. But because I want basically to have a midpoint bearing, I may as well fit ordinary bearings in it, because it's going to have an effect on the motor shaft. Obviously, if that axle is moving forwards or backwards and we trim the axle to exactly where it needs to be, if we move it back, you're gaining a gap. If you move it forwards, you're going to be pushing this brass up against the motor. So I may as well just fit standard bearings into this chassis and put the axle where it needs to be anyway and save these bearings for another job. So what I'll do is I'll change these bearings over now to these standard bearings, which will centralize my axle and lower the chassis down by a fraction, and then we'll move on to fitting the motor. Okay, so I've replaced my eccentric bearings with standard bearings, which has now given me a ground clearance of 1.5mm, and my gear is nice and flush at the bottom of the chassis, so that's all good to go, and I've got a really nice free axle. So now what I need to do is fit my motor. Trouble is, the motor shaft is too long, so we need to chop the motor shaft down. So the way that I do it is I push my motor shaft up to the gullet of that gear, and I put a drill down between the motor and the bulkhead that's the right size so I get clearance, and it's almost touching that gear but not quite. Now this drill is 2.5mm in diameter, so that I know that this shaft is 2.5mm too long. So what I'm going to do is I'm going to get a Sharpie, and I'm just going to paint the end of that motor shaft in Sharpie. So then what you do, get your vernier and measure the entire length of the motor like that, and then zero it. So once you've zeroed it, you now know that that meter now has to read minus 2.5mm. So if you bring 2.5mm up straight off the bat, 2.55, that's close enough for here. So we can pop that jaw on the end of that motor shaft there and just kind of mark the end of that motor shaft all the way around, and now that will give you some idea of where you need to cut it. So what we do then is we get a little bit of Tamiya masking tape, or any masking tape to be fair, and then you could put the masking tape on that line and then wrap it around like that. So then we can double check and we can see that it's bang on the money. So what we now need to do is get a standard 9-volt battery and spin up the motor. And then what we'll do, while the motor is spinning, I'll take my Dremel and I'll cut the axle whilst it's spinning, and then I can come in and I can measure it and then adjust it to length with the Dremel as I go. So let's just do that before we move on to the next step. Okay, so that's done. So if we take the tape off now, because we don't really need that anymore, and by doing it with the motor running, you ensure a nice straight cut. So now if we measure that, we'll see how close we got. And it's only approximate, it's not that important. There we are, minus 2.35mm. So we're a little tiny bit long, which is great. So now what I'm going to do is I'm going to bring the Dremel back up to the end of the motor and just tickle it a little tiny bit, and then I'm going to bring the cutter at a slight angle to put a very slight chamfer on that edge, just so that it's not too sharp. So let's do that now. Okay, so that's the motor shaft now, all cut down in length, and as you saw right at the end, when I was happy with the length of my shaft, I just put the cutter against the corner of that shaft there at 45 degrees and just took the edge off of it. Then I polished the end up with a little bit of 1500 grit, wet and dry. So the length of my shaft now I was aiming for minus 2.5 mil, is minus 2.6 mil, which is exactly what I wanted. 2.5 mil was the exact length, but I wanted a little tiny bit of clearance as well, so I opted for another 1/10 of a millimeter. So when we fit the motor into the chassis, you just drop it down at an angle into the hole at the front, pull the motor backwards and push it down, and you'll find that it'll drop into this spacing perfectly, and it'll just seat into the bottom of the chassis nice and flush. So now what we'll see is we should see a little tiny bit of daylight between the back of that gear and the end of that motor shaft. I'm not sure if it's going to come through in camera, but that's what we should be having, and I have got it. I can see it here, and that is absolutely perfect. We've still got a good amount of engagement into that gear, and the motor is free to turn. So the motor is now perfect. Now all we need to do is get the pinion on it. Now I'm not a huge fan of these old crude pinion pushers, but it's pretty much the industry standard. So bear with me while I just push this pinion onto this motor, and it could be a little bit tricky and a little bit of a balancing act, so bear with me for a moment. There it goes in there. So we'll just push him in like that, and then we'll just see where we're at. Okay, so that's gone a little bit too far, so I want to take him back out now. I just want to pull him back out just a hair on the opposite side of the tool. That's probably enough. Again, push him all the way in, make him flush with the chassis, and I'm happy with that. That's perfect. Right, so now the pinion is in, and that's all happy, and we got good clearance on the motor shaft. You will see that there's a little bit of play there. Now that we need to get gone. So the way to do that is twofold. You can do it one of two ways. You can either fit some shims in the side of this gear here to control that backlash, and over here as well. Not that it's really necessary over there, but I guess it might help. Or you could put a little spacer on the end of the motor shaft, and that is where a piece of 2mm stainless steel tube comes in. Now this 2mm tube is available on eBay. It's a straightforward 2mm stainless steel tube with a 1mm hole, and all you do is you get a 1.5mm drill and put the drill into your drill, and you drill into the end of your shaft about 5mm or so to open up that shaft to 1.5mm, and that means that it will then slide onto the end of your motor. So once you've gotten that far, you get yourself a toothpick and you push the toothpick into the end of the stainless steel tube, and you get your Dremel with a cut-off wheel, and you just cut off however much tube you need to take up that distance. Now, by the judging of that, I only need as much tube as I've got shaft showing on this motor. So if I offer it up there, I put my thumbnail across there, I get myself a pencil, and then I can just mark it out. I can see that. It might be difficult on screen, but I can see that, and that gives me somewhere to aim to for cutting it off. And the reason why we put a toothpick in there so that we don't have it flying away when we come to cut it. So let me just cut this off, and then I'll show you the next step. Okay, so now you've cut your tube off the end of your main tube, what you can do now is slide the end over the motor so it fits nicely, and just take a note of how much too long that tube is now. Take a mental note of that size, and then put the tube back onto your toothpick, and with your Dremel just cut it away and grind it back, and keep offering it up to your motor until the end of this shaft, this tube, is level with the end of your motor shaft, and then you can polish the end up with a little bit of sandpaper, and you should end up with exactly the right size tube. So let's do that now. And there we are, that's it. The motor shaft has had that little sleeve made, and it's now fitting really nicely on the end of the motor there, and it's all nice and smooth. Now I've done it all by hand at this point, so what I think I'll do now is I'll just spin the motor up and I'll just polish that off by hand, just to give it the last little tiny bit of polish. So we'll just go across like this, just making sure we don't lose that piece of tube, because that would be bad. And there we are, that should do the job beautifully. So there we got a nice little chamfer on the end of that shaft, all nice and consistent, no problems at all. And then when we put this into the car, we should find now that it'll locate really nicely into that gear, and there'll be no side float to talk of. There you go, absolutely fine. There's no side float to talk of. All the end float has been completely sorted out by that tube, and it's perfect. So now we need to move on to fitting the motor mount. Now this is a very simple procedure. On eBay I've bought all these screws. They're basically 2mm self tappers. I've got countersunk at 6mm long, and I've got round head at also 6mm long. I think there might actually be 7mm. They're plentiful on eBay, easy to get. And I've taken one, and what I'm going to do is I'm going to put the motor mount into the chassis, slide it all the way up into the back of the motor there, and then simply drill one 2mm hole, or one 1.5mm hole, slap bang in the middle there. And then I shall take the motor mount out, and I shall open up the one in the chassis to 2mm, so the screw can come through it. And I shall put a very small countersink on the underside, and then simply pop the motor plate back in, and then put my self tapper straight in, and that is the motor and pinion gear completely done, ready to go. So let's do that now. Okay, so that's the motor now fully mounted, with the self tapper up front holding the motor mount in, and on the underside we got a nice countersink, all nice and smooth, looking very neat. So in the interest of full disclosure, I did end up changing the pinion for a 5.5mm diameter pinion as opposed to the 4.5mm diameter pinion, because I felt that the backlash was a little bit excessive with the 4.5. Now the backlash is absolutely perfect. You can see that there's just a hair of movement in that gear. So we got a little tiny bit of end float, which is perfect, and a little tiny bit of backlash, and that is now super smooth. Right, so with the chassis now done, or at least the drivetrain, what we now need to do is we need to get this chassis into this body. Now this is very specific to the model that you have, and all it is a simple case of measuring the width, trimming the width, and then measuring and trimming the end, or the ends of your chassis, so that they end up dropping into the body, so the body ends up nice and flush with the bottom of this chassis. And there's no real way of doing this, or measuring it, or doing whatever. It's just a case of getting in there with your Dremel and digging it all out and getting it to fit. So I shall crack on now. I shall make a big mess. I'll take this motor out first, and then make a big mess, and then get this chassis to fit inside the body. Now I won't remove the back axle, just the motor, because I need to guide the chassis into the body using the back wheel as my guide. There's no point taking off huge amounts or leaving it too long and ending up with the chassis in the wrong position. That back wheel needs to be in place so I can guide the chassis in using that wheel arch as a guide. So with that said, let's crack on, let's make some mess, and let's get this chassis into this body. So there we are. That's the chassis now fitting really nicely into the body. Now there's not much I can teach you about doing this job other than the fact that you just got to get stuck in with the tools that you've got and keep going until you achieve the fit that you actually want. So now the chassis is fitting in the body, I now need to secure the chassis to the body. Now this particular car poses a couple of problems because every car is different, so I'm going to come to the front end in a minute. But the back end is slightly easier. As you saw earlier on, I cut deep into this rear bumper to give me good access to that rear mounting fixture. And I left the back end of the chassis nice and long to give me plenty of real estate to put a mount on. So the way I'm going to make the rear mount, I'm going to take this plastic card, I'm going to chop it up into lots of little squares and then glue all the squares together with Mk, and I'm going to glue that block into the back of this chassis with super glue. I shall make it overly high, so then when I mount the chassis back into the chassis will be sitting too high. Then what I should do is I shall file the top of the block down until I get the absolute perfect wheel clearance between the body and the top of the tyre. Now if I go too far, it's not the end of the world because I can always put a spacer in there to fine tune the height. So it's not critical, but it'd be nice if I get it right first time. So once the top of the block is completely filed down and I'm happy with the depth of the chassis fitting into the body, I will then put some white paint on the top of that mount, and then I'll mount the chassis back in, transfer the paint to the block, and then I'll know exactly where to drill my hole. So what I'll do then is I'll drill a 2mm hole or 2.5mm hole all the way through the block and out the bottom, and then I will come in from the bottom of the chassis and go back down through and open it up to, I don't know, maybe 4mm and stop a couple of mils short of the top of that block. That will give me a really nice mounting for the back end of the car where I can then pop a screw in and that gets the back end done. So before we go too much further, let's do that and then we'll come to the front end after we get the back end in place. Okay, so I've made my rear chassis block after a little bit of sanding and filing and fettling into position, and I've opened up my hole to 4mm at the bottom there, and there's a 2.5mm hole in the top. And remember what I said about if you take off too much you can always add more on? Well, that's exactly what I did. I took too much off because I forgot the edge of this valance here does not come flush with the bottom of this chassis here. It actually comes flush with the tops of those vanes there, and I went far too low. No big deal, you just add on a fresh piece of block, add on exactly the right shim, and you're away to go. So with this body now, I can screw it all into place and it all works really, really well. If I screw down this screw here, you'll see I got the wheel clearance exactly spot on both sides of the car. So there is the clearance there, absolutely spot on, and the clearance there, absolutely spot on. So with the back end done, we now need to turn our attentions to this front end. Now there's two different ways that I think I can do this because there's quite a bit of problems going on here. There's not a lot to fix anything to. So my normal way of doing it would be to scuff up the inside of the body around here with my Dremel, really scratch it up, and then put a load of car body filler in that corner, put a bit of sellotape on the chassis with a bit of oil spread on it, a bit of light oil, and then you press the chassis into place. So you squash the top of the car body filler. Then you can simply drill a hole here, countersink it, and then drill and tap into your car body filler, and you can screw here and here with two nice body screws. That would be one way of doing it. The only trouble with this car is there's not a lot supporting it forwards. Well, you've got the great big vanes inside the chassis there. Yeah, I don't really want to go here. So what I've decided to try and do, you'll see this bar has got two different bends in it, and I've been playing around. Up inside, I don't know if I'm going to be able to show you this on camera to be fair. Up in there, there's a gap between the light bar and the underside of the bonnet. And I've bent up my brass wire here so it just fits inside that gap. I'm not sure if this is coming out on camera, but I'll do my best. So it goes up in that gap here. So if I take off the chassis now, I'll show you what I've got as a plan, and hopefully you'll be able to see it clearer. So you've got the edge of this thickness bar here. Now what my plan is to drill a hole 1.6 mil, because this is 1.6 mil brass, drill a hole right in the corner just here and put a 90-degree bend on my brass and come across here, up the side of here in this corner and up to approximately sort of 3 mil above that chassis rail, bend it forwards and then come round on itself. So the top of the brass bar will look just like that as it comes forwards. And with this doubling up this bar, hopefully you now be able to see this lightning bar here. That bar then will go inside that gap, just in there. And of course, with brass, you can adjust it. So I can open up and close this gap, and I can bend the brass around and bend it around until I get it spot on. And I can put one bar that hooks in there, and then one bar that hooks in there. And then what you can do to put the chassis in is you've got two little brass pins there, if you like. So they go into the front there, and then you drop the back end down and then put one screw in the back. So the back end is screwed and the front end is hooked. So sounds quite complicated, but it's pretty straightforward. You just need to be fairly accurate with how you mount the brass, but not that accurate, because as I said, as the brass is mounted like that, you've got a little bit of flexibility on the brass. You can bend it around a little bit. As long as you get your basic bends in the right place to start with, I think we'll be okay. So it's going to be easier to do than it is to talk about it. So let's crack on, let's drill some holes and get this brass bent up and see if I can make this work. Okay, so that wasn't actually terrible. I had to do one of these twice because I didn't quite get the angle right the first time, but it's only little tiny bits of brass. You can just keep on going until you get it right. And it does actually now work, so I'm quite pleased, to be fair. So they're really, really solid and they're all nicely glued in. So the way they work, as you can see, they just hook in to the underside of that light bar, and the back end just simply drops in place. And there we have the back arch is absolutely perfect on both sides, and you can now see, hopefully see, those pins now, they're locking in to the top side of that light bar on both sides, and the bottom of the chassis is completely level with the bottom of that front valance. I'm very, very happy with that. So it took a couple of goes to do one side, but I got there in the end. And you can adjust the height of the chassis just by bending the angles of these two bars here, and they're very slightly pointed inwards as well, and that will do the job nicely. So all they need to do now is just trim up the inside with the Dremel and then give them a quick coat of black to hide all the scuffy marks, and then we can move on to fitting the guide. Okay, so now the body is actually on, I've had a chance to reflect on fitting this chassis to the body, and I think there's probably an easier way to do it. Now the way that I've done it works perfectly well with the pegs, but there's a lot of fiddling around with the width and spacing of these little probes, if you like, and the angle and opening up those jaws as well, and a little bit of filing on the front. And obviously the depth is important. They're about 5 mil deep or 6 mil deep, but it's quite fiddly to do. I'm very happy with the result. It works absolutely beautifully. You just drop them in there, drop in the back, and it's really done. It's a good job. However, I think there's probably a much easier way of doing it in hindsight. Instead of putting mounds of filler on the side here and then sinking your chassis in and then carving all the filler back to make it neat and then drilling your holes, what you could probably do is get your Dremel and Dremel up all this plastic and metal work all around here, make it all nice and rough, and then get yourself a round piece of wood or a round piece of plastic or even a stack of plastic card, exactly the same way as I mounted up all this in the back here, make it into a column, rough that up as well. Put a nice big dob of car body filler on the one end of your piece of whatever you've created, and you can stick it straight into the middle of that body, right in the middle there. Preferably forward of the axle would obviously be my inclination, or rearwards of the axle, sorry, but stick a nice big pile of it right in there. Obviously you don't want to get it down into the glass, so you have to be a little bit careful. And then what you can do is leave it over long and then just start nibbling away at that and make sure it lands somewhere in this region of the chassis, and then it's just a simple case of another screw just here and your job done. And I think that would probably in hindsight be an easier way to do it than the rather convoluted way that I've done here now, although that does work absolutely great and it does register everything in beautifully, but it is a little bit of a fiddle. And I have actually spent an extra sort of half an hour off camera just tweaking these little probes just to make sure that they really do fit in perfectly like they do now with no flex whatsoever. Anyway, that's job done. We're moving on. So the next thing we need to do is to get the guide in. Now I'm going to say right off the bat, I've actually developed this reaming tool and I do sell them. I'm not saying this because I want to sell these reaming tools, although obviously if you want to buy one that would be fantastic. The reason why I've got this reaming tool is because I always use these Slotting Plus guides, and for the last forever how long I've always struggled to match the taper on that shaft. It's not enough really to just drill a 3.6mm hole and put this guide straight in it. If you do that, you're going to end up with a slightly sloppy guide. It works, but it's not brilliant. And to get it right, it needs to be a taper. It's very, very slight, but it is there. If you can get that into a tapered hole, the fitment of these is easy, and it really is very easy. And that's why I developed this tool. Not to sell it, because I needed it. However, if you want to buy one, I am selling them. But anybody fitting a non-Slotting Plus guide, I don't really know how you would do this going forwards, because there are lots of different guides. And quite honestly, I feel for you. But this tool and this guide is really easy. So having said that, we're going to move forward. I've said my piece about the reaming tool. We'll move forward. Right, so how to get this block into your chassis. Now, it's actually really very easy. Put your chassis on a nice flat block, something like this. Get your guide holder and pop it into the chassis in roughly the area that you think you might want it. Then get yourself a square and put your square right up against the front of the chassis. Then with your guide in a pair of tweezers, you can then put the guide post into this recess of your guide holder and keep it nice and square, and then look at the gap that you're going to get between the corner of your wire holder, I guess, and the front edge of that square. And that is the amount of gap of plastic that you'd have once you've cut the hole in the chassis for these these wire holders to swing in. And that to me looks about right, about sort of 2.5mm or so, but it's up to you. And once you're happy with that distance there and you've moved your block accordingly, remove the guide holder, and then simply mark the back of your guide holder on the chassis. Now obviously with a slot car, the really important measurement is the triangle between the guide and the back wheels, and the further back you have it, the more unstable the chassis, or the more twitchy. The further forward it is, the more stable the car. So if you're really looking for performance, you want to get all of this plastic gone, and you want to get that front corner up as close to that piece of chassis as you can possibly dare, if not even further if you've got this space inside your body. So that would make it really easy. Bring that block all the way forwards, bring this edge to the edge, and then you can remove all of this plastic, and you won't have to do any fancy carving like I'm just about to do. However, I want this chassis to look a little bit professional for my own pride. I'm not going to race it, so I don't care. So I'm setting this back a few mil so that when I put that onto there like that, I got a little bit of plastic running around the front of my guide holder, so when you pick it up you got a nice little arc looking all very professional. So that's what we've got now. We've now got a mark inside there where the back of our guide holder sits, and what I like to do is put some thick super glue in the bottom here, and then I'll pop my guide holder straight onto it, and then when I've pushed it down and it's glued, I get some thin super glue and I'll just wick it down the sides, and that's done. Then what we do is we drill a 3.5mm hole straight through that block and straight out the bottom, and then you can start reaming it with the reaming tool until the guide fits more or less level like that, sort of level there. Then once you've got these tops of these wire holders here to touch the chassis, you can then mark out your arc and start dremeling all that in. And then as you go, as you clear material away so that this guide holder can fit deeper and deeper, you just keep reaming out the bottom, and then you keep going back to the arc, and you do the two together. You ream out the hole, and then you chop away whatever's in your way to stop the guide from swinging, and eventually you'll get the guide all the way in, the hole will be fully reamed, and you'll have a nice arc in the front of your chassis for everything to move. So the whole thing moves in unison. However, if you don't drill a 3.5mm hole straight in there, and you have to open up an existing hole, so an aside really with this reamer. With this reamer you get a 4-inch piece of tube. This is a 4.1 OD and a 3.5 ID. So you drill a 4.1mm hole in there, you rough up the tube, you stick it in with a bit of super glue, and then you can go in with the reaming tool and you can start working the inside of this tube to get yourself a nice reamed hole to take your Slotting Plus guide. But with this chassis you're perfectly good to go. Drill a 3.5mm hole and then you can ream it from the underside from there. Right, so enough of the waffle. I'm going to do this now and I'll come back and show you when the job is done. And there we are. That's the fitting of the guide mounting plate all done. And you can see the nice clean arc that I've put in there and a little tiny bit of plastic at the front. I don't think that you've lost much performance from the triangulation of the guide to the back axle by leaving that little piece in there, and it's only really the amount of gap that you'd have to leave in your front bumper anyway, so I'm happy with that. So as you saw on the body, I had to take away a little bit of metal in there and a little bit of plastic fittings. This is very specific to this particular body. It may not be something that you'll need to do with your car, but it is worth making sure that you've got plenty of clearance on the underside of your bonnet for your guide. And obviously with regards clearance, I dropped the top of this mount down as well, just a little tiny bit, just to get it well clear of the top of these rails and well clear of the body, so it just keeps everything clear, and there's plenty of meat there anyway. Also, one thing to consider is you do want a little tiny bit of guide drop in your chassis. So with that block being so tight, you can have the screw sort of high up, but really, you know, you want a little bit in there, and by the time I've got a packer in there and some braid, that'll be perfect. So with regards to the fitment of the guide, do my little paintbrush trick. You can see just how smooth and easy that guide is to move, and the paintbrush is free to move. And if we just tap the bottom of the guide, you can see it's free to fall. And then with regards to the actual fitment, you can see that it is absolutely rock steady. There's absolutely no play in that guide whatsoever. I'm giving it a good old tug look and there's nothing there. And when I go back to the paintbrush, it's super free to turn and super free to drop. So like I say, I'm not really bigging up my reaming tool, but I kind of am. But I did develop it because I know it works. So I'm not just trying to sell you something for the sake of it. It's a genuine tool and it genuinely does work, and there is the proof right there. Right, so now we've done that, what we now need to move on to is getting the guides onto this guide, the braid, sorry, so that we can set the ride height, get the shim in there, and then get the screw in the top of the guide. Now I've found by putting the screw in the top of the guide presents a bit of a problem. When you've got your guide fitting so well, it's a bit of a problem when you put the screw in, because the screw actually swells the post. So what I like to do with my guides is I got these tungsten carbide bits. They're very, very cheap on eBay, but they're incredibly sharp. They're also incredibly fragile. So if you do use these, be really careful because they will snap just by looking at them. So for this light job, I found them to be very, very good. So what I'm doing is this 1.9mm drill. I'm just drilling out that tube because I don't really want this screw to be biting into the top of this guide very much at all. It's really only just to hold the guide to stop it from falling out the bottom of the car. And the reason why I'm drilling it out is because as you put the thread into the bottom of that, or into that hole, you tend to find that you spread the tube, and that actually stops the guide from moving freely. So if you drill out that tube to 1.9 mil, even possibly 2 mil, you don't actually swell the guide, and it's still very, very free to move. Now this may need a little bit of adjusting as I go, but you can tell doesn't actually look, that's actually really, really good. So that's a 1.9 mil, and that screw is basically all the way home, and I've got this just starting to bind there now. So I back him off just a hair. There you go, look, absolutely perfect. There's plenty of upwards movement in that guide now, and it's still lovely and free to turn with no binding whatsoever. Let's do the old paintbrush on there again. There we go, nice and free. So there we are. So that's a 1.9 mil drill, a little tip for you, and that gives you all the lovely movement that you need. Right, so the next job now is to get my braids in. I'm going to use 0.2 mil thick racing braid because we don't want too much lift on the front end, and also that braid is very, very soft and it doesn't make the car lift up. And it says for racing only, but honestly it's brilliant for everything. So we're going to put some braid on that now, and we'll make a little packer underneath this guide to get the ride height set, and then we can move on to fit in the front axle. And there we are, that's the guide all fitted and finished. And as you saw, I made a very simple 0.25 mil plastic card spacer to go underneath the guide, and along with these super fine 0.2 mil NSR racing braids, I got a really nice ground clearance of 1.5 mil right across the chassis. So with the guide now all made and ready to go, we can now turn our attentions to fitting the front wheels. Okay, so with the front guide now all finished, and that 0.25 mil spacer underneath the guide and my 0.2 mil braids gives me a total chassis height of 1.5 mil right across the bottom. So now I've got my chassis height set, I'm ready to go to set up my front axle. Now the way this works is that scribe line that's on the front of that chassis there is the center line of your back axle if you were to use standard bearings, which if you recall, we did swap the eccentric bearings out for standard bearings. So I can rely on that line being the middle of that axle, as long as my front and rear wheels are exactly the same diameter. And I'm actually using the toy wheels in this particular car, and by luck they are exactly the same diameter. So I can use that line as my line to fit my axle. And I'm also going to be using the toy axle as well, because there's nothing wrong with it. These toy tyres, they're nice and rubbery, but they're nice and firm and they're well glued to the wheel. So I can use the toy axle as my proper axle in this particular case. Now, for example, if you had a 20 mil back wheel and an 18 mil front wheel, that's a difference of 2 mil. So to find your axle center, if you have two different wheels, you take the 20 mil, the 18 mil, subtract it, gives you 2 millimeters spare, half the 2 millimeters, and it's 1 mil. So that's where you would put your axle on that scribe line, is 1 millimeter below that scribe line there, and that will give you the theoretical center of your axle if you were using, for example, a 20 mil and an 18 mil wheel. So deduct the front from the back, take the difference, half it, and then go below that line by the distance of half the difference of the two wheels. So that's how you would find out where your axle goes. So just to show the fact here, if I take my vernier and I put it in the middle of that axle, just there, more or less, just quickly here now, and I come over to the front of my chassis, you can now see that that falls exactly on that line. So we know that we can rely on that line to be accurate. So how do we find out where to put our axle hole? Well, that's quite straightforward as well. If we put the chassis back into the car, and then we put our wheel into the wheel arch, and I've gone ahead and I've cut out for the front wheels because it's just a case of marking out and hogging it out with a Dremel, no big deal. So get the wheel exactly where we want it in the arch, and then we measure exactly the centers of the wheel where you want it. Now I'm going to say that I want 66.5 mil. I think that would be perfect for my front wheel. So 66.5. So now what we do is we take a stick and then we take a 2.3 mil drill and we drill a hole in the back of the stick to 2.3 mil. Just like that. Then we can take a wheel off the car. In fact, you may as well take both wheels off at this point, but I'll take one off for a second actually. And then we'll try up that hole on the axle. Now as you can see, it's a little bit tight, which is exactly what I intended. Now what you would normally do is you'd open that hole up with a broach, a very tapered reamer, but most people don't have broaches, so we'll do it the crude way, and we'll do it with this scalpel. And what you're looking for is a really nice tight fit onto that axle there. Now that's perfect. See, it's so tight as it's not slipping on that axle. So that's what you want. Then once you've got that, you can take that off and then mark out your 66.5 mil in the case of my car onto that stick. And then once you've marked out your mark, drill another hole, and this time drill a hole at the same diameter as your axle. In this case it's 2 millimeters. And there's your hole there. Just double check your axle through the hole to make sure that it's correct size, which it is. Right, so then now what you do, we can take off the back wheel, here the other one, and then we put our stick on the back wheel and slide the stick all the way to the back of the chassis like that. And now what you can do is you can put your drill in that hole and you can feel where that groove is, and it's just there. So then we just make a mark. As you can see, there is the mark right there. And then you could do the same on the opposite side. And that marks out exactly where your front axle will go. Hopefully you'll see that mark there nice and clearly. So now you've got your mark on both sides. All you simply do is drill in halfway from one side, drill in halfway from the other side, and that should be exactly where your axle goes. And there we are. With your hole drilled, you should find that when you put your wheel in, you'll get exactly in the right place on your chassis, just like that. And if you go on the other side, you should find it's exactly the same again, which it is. However, I've got another way to fit the front axle. You may have noticed all through that last segment, I've actually had a brass tube sat here. Well, this brass tube is a 2 mil bore brass tube, and it fits perfectly on the axle. And when you put the other wheel on and push tight, you get the perfect amount of end flow on the axle, and the wheels spin very freely. So what you do, if you want to fit a nice big bearing in the front of your car, or you get the hole slightly wrong, or you're just not happy with the fitment of your axle in the first place, you have to go through step one first to get to this step. What you would do is you would take a series of progressively wider drills and open up that hole that you've just done until you get to the outside diameter of that piece of brass tube. And that brass tube, you can buy that from anywhere, from K&S or eBay or anywhere like that. And all you do is you just open up this hole and keep going until you get to exactly the right size to take that brass tube. And there we are. So that's what you're trying to achieve by any means possible, to get that axle tube straight the way through your chassis. And you do want it nice and slack, so you want to overbore it as much as needs be so you can get a nice bit of play in there. Then what you can do is you can pop your wheel into the axle tube, put your body back on, and then recheck the position of your axle and see if you're happy with it. Now what you're looking for is you want to overshoot your mark. So you want to be able to have the wheel drop down further than you want it to and you want it to go up further than you want it, and you want it to go forwards and back more than you want it. Now, as I've been drilling out this hole, my wheel has crept forward a little bit. So what I need to do is slot the hole to have the wheel come back. Height wise it's not too bad. I think I'm within target there. So that's that side. Now the other side, let's see how close I am on the other side. Pop the wheel in, and there we are. Right, so the wheel has gone that way a little bit too far, I can see, and I could do with a little bit more vertical movement possibly. So I'll go in and I'll tickle this hole a little tiny bit more and come back and keep checking until I've got excess movement in that hole, and then I'll come back to you. Okay, so after you've finished filing and dremeling the axle tube slot, what you're looking for is a really slack fit, so that when you assemble your whole front axle completely and you mount it back onto your setup block and then mount your body on, you're looking for excess movement in that front wheel well beyond what you actually want to set the wheel at. And make sure you've got plenty of drop as well, so the wheel drops down and touches the setup plate. And then mix up some 2-part slow setting epoxy, and then set up your front axle and then mount the body on and make sure everything is exactly where you want it, and then position the front wheel exactly where you want it to be, and then leave it to set for as long as it takes your aldite to set up. And then once you've finished, you should have an absolutely perfectly set up front wheel that's just touching the setup plate as it should be. It should be free to spin and exactly where you want it to be. So let's do that. Let's get some aldite all knocked up and get this glued into place. Okay, so after about an hour of my epoxy drying, I've now got my front wheels completely secured in place, and they are exactly at the right height. When you move the plate, they're just about touching the ground, the front wheels, and that's absolutely perfect. And as you can see, they're absolutely spot on inside the arches. So that's a real foolproof way of setting up your front axle in bearings, all nicely controlled, and they'll land exactly where you want them every single time. So if we just take off the body now, I can show you how I went about gluing them in, just to be safe. So the way that I did it is I put glue on this part here, and then this part here, and then I rotated the axle around with a pair of tweezers to drag that glue all the way around. And that means that you don't get any glue in the ends of your axles, and if you added an oiling hole like I have here, you won't get any glue down inside that oiling hole. If you only put the glue on the sides and then just rotate it around quietly, you won't get any glue anywhere that you don't want it. So it's a 100% foolproof way of getting a front axle in, and you get a lovely bearing in there and all nice controlled end flow, and you can control exactly where the wheels land in the wheel arches. Right, so that is the front axle completely finished. Next, we need to trim this back axle now, because it's time to trim it down to its correct length. And we also need to get these inserts out of these wheels and into these aluminium wheels. Now, normally what I would do, if you've watched this channel for any amount of time, is stick these wheels straight into my lathe, couple of cuts, and they're done. But obviously, not everybody's got a lathe, and I would like this chassis to be able to be built by anybody, not just someone with a lathe. So I'm going to show you how, very easily, to get the centers of these wheels out of these wheels as if you had a lathe, but you don't have a lathe. But you will require an ordinary electric drill, battery one or mains powered. So as long as you've got an electric drill, you can do this very, very easily. So let's crack on with that, and I'll show you how to get these wheels as centers for the alloy wheels. Okay, so the first thing you're going to want to do is get yourself a really, really sturdy pair of pliers and cut the back axle from your pullback and go system if you've got a pullback and go system. If you don't have a pullback and go system and you just got a plain axle, then you want to cut the axle straight in half. Next thing you're going to want to do is measure the inside of your alloy wheel and familiarize yourself with the width of it. So in my case, it's pretty much 10 mil. Then what you're going to want to do is offer that size up to the wheel just to see whereabouts you're aiming to cut your wheel, because it could land on the rim or it could land in the spoke. On this particular wheel, it's kind of landing a bit on both. It's actually taking away all of the spoke, but it's actually still landing inside of a little extra piece of rim back from the spoke, so I'm kind of a bit of both in that case. So then what you want to do, because I need to get rid of all of this rim, but this tyre is really well glued on, what I'm going to do is I'm going to go round and I'm going to cut all that excess tyre off this rim to reduce the amount of material that I've got to take off when I put this wheel on the drill. So it's just a simple case of going round and chopping off all this tyre. Just like that. That's good enough. Then what we want to do is you need to get a drill, either a battery one or a mains one, and mount your drill into a vise or something clamped down to a workbench with this wheel clamped in it. Okay, so I've mounted my model wheel with this little stub axle into my little pin drill because the chuck on my big drill is too big to take this 2mm axle. I've also got my alloy wheel at hand so that I can check as I go, and I've bonded a piece of 120 grit wet and dry sandpaper to a piece of 6mm MDF. So all I'm going to do is I'm going to mount this into my chuck. I'm going to start the drill up and I'm just going to very gently rub the wheel on the sandpaper, and every so often I'm going to check to make sure that I'm not getting too small. The only thing to make sure of is don't go too quick with the sandpaper, because the last thing you want to do is melt that wheel because you've only got one. Right, so let's turn this drill on and let's do a little bit of sanding. And there we are. The insert, as it is now, fits perfectly on the inside of that alloy wheel, no problems whatsoever. The only thing I had to do halfway through was trim off this piece of wood here because it was just catching on the chuck of my pin vise. So what to do now? I've got to measure the depth of this wheel and transfer that depth onto the face of this wheel and the back of that boss, and basically just chop the boss off to the length so that when I push this insert into this wheel, the spokes come just below the level of the inside of that alloy wheel to a depth that I'm happy with. Okay, so now we've got our wheels completely finished and painted, it's time now to cut the back axle. Now the way that I like to cut these axles to make sure that I don't get it wrong is I put the axle in the wheel all the way to the back of that insert. Then I put the axle into the car and pop the other wheel on and just loosely nip it up for a second, just like that. And then pop the chassis on your setup plate with the wheel all the way over to one side. Then remount your body and get the body down on the chassis exactly where it should be, and make sure that one of the wheels, in this case my driver's side wheel here, is completely flush with the wheel arch. Then I get my vernier and I measure the distance between the outside of the wheel and that wheel arch just there, and in this case it's 12.8mm. So now I know that my axle is 12.8mm too long. So what I can do then, with a Sharpie, I can mark out the 12.8mm on the axle and cut it down to exactly that. So the way that I can check that now, if I come out on my vernier and hold my axle there, I can zero my vernier like that, and now I can move it in 12.8mm and I will get exactly the right measurement to cut to. So there is 12.9, 12.85, close enough for me for now. So if you take a Sharpie, you can put a little mark there and that'll be in the ballpark. So let's cut this axle and keep testing it until I get to 12.8mm, and we should find that the wheels fit perfectly inside the arches of that car. And there we are, that's the back axle completely cut to exactly the right length. The last job to do now is to cut this interior and get it all chopped out and then fit the motor with the wires. The next clip you'll see this all chopped out and the motor all in place. Okay, this is very exciting. We're only one screw away from finishing this whole car right now. So obviously this is the interior, and you can see how much I've had to chop away to make it clear my chassis. You can see I've fitted a little 3D printed driver there from eBay, and it's got some seat belts on him from some sign writing vinyl. And I've also taken the dashboard out of the main body and stuck it to the interior because it's much easier to control. And I also took the steering wheel out and glued it to the driver, and then I glued the driver in via the side of his leg and the back of the steering wheel to get him seated in the right position, and then I fitted his seat around him afterwards. That gave me the greatest control of getting this all in place. I've also taken away all the rear arches because it's unnecessary weight that we don't need, and I've obviously taken away all the stuff at the front that was there to give the doors their springing because we didn't need that either. And this is what we got left. Quite a bit. I had to chop out quite a lot of the man to get him in, but to be fair, you barely see anything of the lower half of him anyway, so that's not a problem. So here's the chassis all finished with all the wires and everything, and I put a little bit of a black wrap over the top of the motor just so it doesn't show silver through the interior. And there's the underside all completely done, and a very nice self-centering guide. Works super smooth. So all we need to do now is we need to put the interior into the car, just drop him in like that, and then just put the chassis into the body and put one screw in the back and do him up, and we've got ourselves a finished car. There you go, all finished. So that's that, and that's your driver all in there as well, all looking great. Right, now it's got to show you the Delahaye. Okay, the beautiful Delahaye 145. Now this build couldn't have been more different if it had tried from the BMW. So I did actually build the whole back end in about 10 minutes with all the standard Scalextric parts, fitted the motor in, all went beautifully. Then I turned my attentions to the chassis and realised that the standard die-cast chassis is basically flat and it fits nicely inside the body of the main body there, so it's all fitting really well. So my idea was to simply take the chassis, lay it on the underside of my resin, trace around it and cut it out, and that went really well. And before I knew it, I was actually taking off the bumpers and side skirts that were normally fitted to the die-cast chassis and actually fitting them onto my resin chassis, getting them all lined up, and that all went absolutely beautifully, no problems whatsoever. And then I came to put all the back end back into the car because I had it all removed to cut the chassis out, and I realised that the wheels were far too high up into the arch. They were sinking far too high, i.e. the chassis isn't designed to be this high off the ground because we're looking at about 4mm of ground clearance. It's just not really designed for that. So I tried the eccentric bearings that I was going to use in the BMW, but ended up using ordinary bearings, and even they weren't enough to drop the back axle down. So I ended up making these brass plate bearings and drilled the hole right at the very bottom, and I fixed them into place with two copper rivets on either side once I'd had them in exactly the right place to fit the body, and that went really well. A bit fiddly to make, but it got there in the end. And then obviously the motor had to then be pointed downhill because I dropped the axle so low, so I just had to dig out where the motor goes and just drop it down, clearance for the pinion as well. So now we've got about 1.5 mil of motor showing here, so it's on a down, it's flush here and about 1.5 mil here, so it's pointing downhill, a little bit like some Scalextric cars are. So that's all good. Once I got the back end in, that was all done. The body itself was very easy. Just had to trim a little bit off the front grille here just to get some clearance because that was a moulding that intruded. There's a post here that was holding the back half of these front wheel arches across there. That was just getting in the way. We got a really big one there anyway, which is enough for this car. So that could go, and that was getting in the way of this bulkhead, so I just chopped him off. And the rest of it was pretty straightforward. Just cleaned up the tops of these posts here, drilled some 2mm holes in there so I could fit my 2.1mm self-tappers. 0.1 of a mil is more than enough with die-cast and self-tappers. If you go too hard, in fact, you can snap the screw. It still offers that much resistance. And the body was basically done. So there's very little that I needed to do to the body other than clearance for the guide and cut away that cross member there. So on to the other part of the chassis now, the front end. Now the front end was relatively straightforward. I was able to fit the guide mount straight in there, but you'll notice, or maybe you won't for a second, but you will when I show you, there's a 2mm or 2.5mm resin packer just inside that guide there, because the guide, again, because the chassis is so high off the ground, I didn't really want a 2mm packer there that was unglued to the chassis and unsupported. So I glued the piece of resin in, which meant the hole actually starts, for the support hole for the post for the guide starts at the bottom of the actual guide and not going through a loose spacer. So it just gives it a lot more rigidity. So that was pretty straightforward, and I had to machine down the front of the guide holder there to allow, obviously that's all fine. But the other thing you'll notice is this car has had to have stub axles. Now that's because, as you can see from the axle, there is absolutely no way that I would have been able to put a single straight axle in there. There's just no way. So I had to make two little tiny axles, stub axles with little domed ends, run them in bearings, and then I had to make up these resin blocks and glue them into place, and then drill a nice big hole, very similar to the BMW, where I was able to adjust around, get it in the right place, put a spot of super glue in there, and then that locked in the independent front axles, which actually turned out really well. And then the motor in itself, as I said, is just a standard 16k motor. This car is not performance orientated. As long as it drives around the track, I'm going to be perfectly happy with that. And the front and rear mounting for the body, this was actually super easy on this car. No convoluted hooks at the front. Again, a very different experience from the BMW, because this was really easy to mount. All I did is I just drilled out a nice big hole in the front there, machined it flat with a Dremel, and then used a bit of paint on the bottom of the post, put the body on, got exactly where the hole was, drilled a straightforward hole and out the bottom. The back was super easy. It's just literally, because it's mimicking the Diecast chassis, I was able to just simply drill a hole, and I put a little spacer washer in there. It's about 0.2 of a mil, 0.3 of a mil, just to make sure that it wasn't crimping or bending the body. No problems whatsoever. And then I was able to turn my attentions to the actual interior. Now, I've got to be honest, this interior did fight me quite a bit. It took me a good while to get this interior in. It all seemed pretty easy at the beginning. I just chomp out a piece out the middle just so it fits over the top, and that should be done. But it wasn't that simple. It all fell apart. It was all loose and going out of square, and everything was all a bit flimsy. And I managed to stiffen it up as I went by reinforcing the corners with glue, and I ended up having to take away almost all of the back end there and then put in this parcel shelf and so on and so forth. But I got there in the end. It's no problem at all. Then the last thing that I found was that there's nothing actually anchoring this interior into the body lengthways. It was free to sort of move back a bit. So the post that used to be across the back of these arches turned up useful for making a sort of an anchor point for the interior. So now it actually works really, really well, and the actual finished product is absolutely happy. Well, I'm absolutely happy with it. It looks really, really nice. You don't really see that high floor in there in any meaningful way, and it copies the original model with the red interior perfectly. So I'm very, very happy with that. Now, there is actually a figure coming for this interior. I didn't actually order it in time on eBay, but he is on his way. It's a classic guy driving in sort of classic attire, and I would like to try and get a lady as well to go on the other side in sort of classic attire as well. So I'm actually looking at a couple of people on eBay at the moment who 3D print 1/43 scale figures. I'm in conversation with them, and I might be able to do something with them going forward, so watch this space. But I will put a little short video in a month or so's time when I got the figures of the two guys, or the lady and the man, in the front here on the turntable, and we'll do a little short on that, so keep your eye open for that. So all we do to put this car back together again is pop the interior in, really, really easy, and then just drop your chassis in. And then we got two simple screws, front and rear. Now there's a little bit of a secret to the front screw. I'll show that to you in a second now, once I've screwed this in. So the secret is I didn't have room to put the screw beneath this guide. So what I've had to do is just munch out the corner of that guide ever so slightly, and now I can actually get the screw down past the guide. Doesn't actually make any difference to the performance of the guide. It just means that I'm able to get that screw in there, and then we can simply screw the screw straight in, straight past that guide. And there's the Delahaye, completely finished and ready to go. And there's the actual screw just hidden underneath the guide there. So there we are, that's what she looks like. All done. Okay, so with that said, let's go and put these on the turntable and hit the track. we are. That's my brand new Mk2 resin chassis for converting 1/43 scale die-cast cars into slot cars put through its paces. So remember, if you want any of these parts, the chassis or the tyres, all the links are down below. And if you want to get one in time for your Christmas holiday build, better get your orders in quick, because I'm going to be quite busy in the next couple of weeks getting these out to customers that have already placed their orders. So how did these cars go around the track? Well, the BMW was obviously the quicker car and the car we took a time for. And to be honest with you, I was rather hoping that it would be a little bit quicker than it actually was. However, the trouble with this car is it's so long. This is my fastest car, my Renault Megane. So she's a 56 something. So this BMW is a 59 something. So it's 3 seconds short. But if you look at this picture just here, you'll understand why the BMW is just a little bit slower than my Renault. She's 15 millimeters longer in overall body and 8 mil longer in wheelbase. And she has a hard time trying to translate the straight line speed into a corner, so she tends to slide the back end out. She's incredibly stable, incredibly smooth, and really quick. It doesn't lack for power at all. It's just as it comes to the bend, the whole length of them, the weight and all that bodywork hanging beyond the guide just wants to keep on going forwards, and she slides around a little bit. But she's really stable and really nice to drive. And the Delahaye, well, that was never going to be a performance car in the first place. However, I am absolutely amazed at how well she does actually go. I did take a kind of time for it. She's about a 68 seconds, so she's quite a bit slower than these cars here. But then she's always going to be. There's only a 16,000k motor in this car, and it's on skinny little tyres with a really tall body, and she's really narrow. That said, she still runs really well. I'm very pleased with it. She's very smooth and very stable, and you can even get the back end out, as you see in the video, as you saw in the video there. She does slide around a little bit. She doesn't want to roll over at all. She's incredibly stable. I'm very pleased with it. And the weight of it, 120 grams. So to be fair, she doesn't have weight on her side. She's a little bit porky, but that said, she still goes really well. I'm very pleased. So she's a lovely cruising car. And this car, although not as fast as I would like it to have been, hardly surprising given its length, and the fact that it goes almost as well as my Renault, I'm very happy with this conversion as well. This is the fun of die-cast cars. You never really know what you're going to get. It's a bit of a mixed bag. It's a bit of a pick and mix. You can get a car and you think, that'll be really good. By the time you converted it, you don't really know. It could be bad, it could be great. It's difficult to tell with a die-cast car because the weight's all in different places, and obviously the weight's very high up. You can't put weight where you want it to be because the bodies are so heavy. You can't really put more weight in them. So you get what you get. It's all good fun, and you should definitely have a go. So if you've enjoyed this video, maybe you'd subscribe. And if you could hit the little bell button, that would be awesome. So until the next time, thank you very much.